day 4 in advanced geometry. Today we're going to learn about rhombuses, rectangles, and squares. We've already learned the top of our hierarchy, which basically that's it. All we need to find are like the parents of these particular guys. So let's pick on the rectangle first. And you can see that the rectangle comes from the parallelogram and the isosceles trapezoid, so those are like the parents. All we have to do is like put the properties together. So obviously the first thing is the definition. It's got 4 right angles. When it comes to symmetry lines, though, we look to the parents, right? The parallelogram has no symmetry lines. The isosceles trapezoid does have symmetry lines, so that means that a rectangle will have symmetry lines. Where are they? Well, let's base it off the parents. If the isosceles trapezoid symmetry line is the perpendicular bisector of the bases, and don't forget, the bases are the parallel sides, right? Then that should happen down here in the rectangle also. Well, the thing is, you know, the rectangle does have 2 pairs of parallel sides, right? It is a parallelogram. These guys are parallel to each other, right here. So if the symmetry line is supposed to be the perpendicular bisector of the bases, right there, there would be like a symmetry line for this bad boy. Ba-boom. It would go like so. And also, shouldn't these guys be parallel to each other? Bada boom, bada boom. So if the line that perpendicularly bisects those bases, I mean those are bases too, that's also a symmetry line. So a rectangle has 2 symmetry lines, the perpendicular bisectors of the sides. We get rid of the word bases and we're going to call it sides now because the sides of a rectangle are parallel to each other. And then when it comes to the diagonals, that's where my peanut butter every day comes in. These bisect each other, and these are equal, so we just got to put them together. And the diagonals of a rectangle are equal and bisect each other. They are the same length, boom. They cut each other into 2 equal pieces, boom, but they do not intersect at a 90. So if we have a picture like this, pretend the red one was like 10 units long. So then it got bisected. The green one cut it into 2 equal pieces, so shouldn't it be 5 and 5? Well, if the red one's 10 units long, the green one's got to be 10 units long also because they're equal, and it also got cut into 2 equal pieces, so that's got to be 5 and 5 also. And what's going to help you on your homework is to realize that these shapes in here are not just triangles, my friends. They are isosceles triangles. They are definitely isosceles triangles. So, for example, like if this angle right here was, say, 30 degrees, then this angle right here has got to be 30 degrees because that's an isosceles triangle and the base angles are equal. Or you could think of the fact that there's a symmetry line right here, and 30's got to be the same as 30. So not only are there triangles in the picture when you draw 2 diagonals in a rectangle, they're isosceles triangles. So let's do some rectangle problems. Here they say the distance from A to C is 2x plus 13. That's a diagonal right there. And the distance from D to B is 4x minus 1. That's the other diagonal. Since we know the diagonals are equal and bisect each other, they're definitely equal, we'll set those 2 expressions equal to each other and solve for x. So subtract 2x from both sides, add 1, and then divide by 2, and x should equal 7. They ask us to find the distance from D to B, so we need to substitute in. Here's the distance from D to B. It's 4 times 7, which is 28. Take away 1, so the distance from D to B equals, I got lost that, 27. And then here, they say the distance from A to E is 3x plus 3, which is just this little guy right here. And the distance from E to C is 5x minus 15. Well, don't forget that the diagonals bisect each other also. So I'm of the belief that anytime you see a rectangle, you should put like the 4 tick marks in there so you can see things happening. And we can just set those 2 dudes equal to each other. So 3x plus 3 equals 5x minus 15. That's what the tick marks mean. So subtract 2x. Sorry, 3x and get 2x, that's what I meant to say. And then add 15 to both sides, get 18, and then divide by 2. X equals 9. They want me to find the distance from A to C. That's this whole mamma jamma. Well, I'll substitute in 3 times 9 is 27, 28 times 30, So that's 30, and then this better be 30 also. 9 times 5 is 45, take away 15 is 30. Distance from A to C equals 60. If the measure of angle DAC from D to A to C, this angle right here is 2x plus 4, and the measure of angle BAC is 3x plus 1. Find the measure of angle BAC. Well, this is a rectangle, and don't forget, the definition of a rectangle is it's got 4 right angles. This entire blue thing should be 90 degrees. So I can add those puppies together and set that equal to 90. So 5x plus 5 equals 90. Let's solve that for x. So 5x equals 85. And then divide, x equals 17. They want the measure of angle BAC, so that's this red one right here. So I'll put 17 in for x. 17 times 3 would be 30, and 21, which is 52. Measure of angle BAC equals 52 degrees. Right, because that's 51 plus 1. Yeah. And we'll skip over number 4 here. Proof time, right? What do they give me? That's the big question. Then what are we trying to prove? So they give me RSTV is a rectangle. We'll need to use that. And they also give me a dirty word. U is the midpoint of segment VT. So since they gave me a dirty word, let's use it right away. Use the midpoint, boom, boom, and write it down. Definition, midpoint. Now look at what you want to prove. We're trying to prove these two triangles right here congruent to each other. Well, we got to use a little bit of hierarchy knowledge. First thing I think of is it's a rectangle, right? So we can get some right angles out of it. But I want to see if I can get some more sides first before I'm going to get any angles. So let's check to see if we can get some sides. Since this is a rectangle, its parents are the parallelogram, so anything that's true about parallelograms is also true for rectangles. And don't we know that opposite sides are equal in a parallelogram? So we know that these sides got to be the same, because since this is a parallelogram and those are opposite sides, segment RV has to be congruent to segment ST, because opposite sides of a parallelogram are congruent. And that seems a little weird. It's like parallelogram, dude, they gave me a rectangle, right? You got to realize a rectangle is a parallelogram, so we can use all that information. And now it looks like, you know, I got a couple sets of sides. I can get me some angles real easy because this is a rectangle, so shouldn't all 4 angles be 90 degrees? These are the 2 that I'm really concerned about. So here's what we got to say. We're going to say that measure of angle V equals 90 degrees. And the measure of angle T equals 90 degrees. Reason, because that's the meaning of a rectangle. That's the definition of a rectangle right there. And then what I really got to do to be able to do side angle side on these bad boys is get a set of angles congruent to each other. So I got 2 sets of sides. Here's a side. Here's another set of sides. I need a set of angles, though. So step 5, since those are both 90, I can cross out the 90s and say angle V has to be congruent to angle T by the transitive property. And then finally, we got ourselves a side angle side situation. So, nice. Now to the rhombus, right? Its parents are the kite and the parallelogram. When it comes to the definition, we should know that by now. That's got 4 equal sides. Symmetry lines. Kite does have some symmetry. Parallelogram does not. So that means a rhombus will have some symmetry. Where's the symmetry lines of a kite? Through the ends. So that's got to happen down here also. It's got to go through the ends. And a lot of people are like, I didn't even think a rhombus is a kite. Remember, to be a kite, All you got to do is have two distinct pair of consecutive sides equal. This does. Even though all four sides are the same, it's got two different sets of sides that are consecutive and they're the same. So, since the symmetry line goes through the ends, and the ends of a kite are where the two sides of the same touch, don't two sides of the same touch right here, and two sides of the same touch right here, and here, and here. So if I was to like draw a line that goes through those, but I'm not going to draw a line, give me a second, sorry. If I was to connect those, there's like a symmetry line. Even though I didn't draw a line, I drew a segment. Those went through the ends, and so did this guy go through the ends. And if you just take a step back, it's like, what did I really draw? I drew the diagonals of that rhombus. So the symmetry line for a kite is, I said kite again. The symmetry lines for a rhombus is there are two of them, right? Tell me how many there are, and then say that they're the diagonals. And then when it comes to the diagonals, remember my peanut butter every day idea? So these were perpendicular, these bisect each other, put them together, and the diagonals of a rhombus should perpendicularly bisect each other. Perpendicularly bisect each other. That means that yes, they do intersect at a 90. Ba-boom. Yes, they do cut each other into two equal pieces. So boom, 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 boom. But no, they were not the same length, right? The red one and the green one are different lengths because this doesn't say that they are equal to each other. So let's do some rhombus problems. It says ABCD is a rhombus. The big trick is to go straight to the diagonals and know that they're perpendicular to each other because the diagonals perpendicularly bisect each other. And let's find some missing sides. When we do that, we get right triangles all over the place. I want a highlighter. That's what I want. Here's a right triangle. I am missing the hypotenuse right here, so I could set up my Pythagorean theorem and do 3 squared plus 4 squared should equal the distance from B to C squared. 3 squared is a 9. 4 squared is a 16. That equals the distance from B to C squared. 25 equals the distance from B to C squared when you add those together. And then we'll square root both sides and get that to be 5. Oh yeah, didn't you ask us to remember that, Mr. P? 3, 4, 5 is the most popular right triangle around. So if you have that committed to memory, you don't have to show me this Pythagorean theorem work. But if you don't have it committed to memory, time to do the Pythagorean theorem. Awesome. Now, since it's a rhombus, if this side's 5, all the other sides have to be 5. So that's nice. Then let's use some symmetry lines. Isn't this bad boy right here, let's use a different color, that's what I was trying to do. And this bad boy right here, one of the diagonals, it's a symmetry line, so if this guy's 3, that guy's got to be 3. If this guy's 4, that guy's got to be 4. So, nice. You could also think of it as the fact that the diagonals bisect each other, because they perpendicularly bisect each other. Still based on symmetry, here's another symmetry line for this bad boy, the other diagonal. So these two red things right here are the symmetry lines. If this is 32 degrees, this has got to be 32 degrees. And jump over the red one. If that's 32, that's got to be 32. And same thing right here. And then to find the last angle, again, remember the green shape here is a triangle. So this is 32, this is 90. The only angle missing has got to be 58 degrees, and then it's all over the place. 58, 58, 58, 58. Sweet. So rhombuses, easier than you think if you know about the symmetry lines and the diagonals. Symmetry lines and the diagonals. Here, they give me rhombuses again. They say if the measure of angle ABD, that guy right there, is 60 degrees. Find the measure of angle BDC. So you could do all kinds of tricks, but you could also remember the parents of a rhombus. One of its parents is a parallelogram. And shouldn't this side be parallel to that side, right? It's got two pairs of parallel sides. And you see these dudes are alternate interior angles. If that's 60 degrees, that's got to be 60 degrees. So don't forget about that. You also got parallel lines all over the place with this rhombus. You could have used symmetry if you wanted to and said, hey, if that's 60, this has got to be 60, and this has got to be 60 based on symmetry also. But any which way around it, you'd get 60 degrees. Here, if the distance from A to E is 3x minus 1, right, that's part of the diagonal, And the distance from A to C, whoa, A to C, that's like the whole diagonal right there is 16. I don't like to put the entire diagonal's length in the picture if they have both of them drawn, because it's like they cross each other, and it's like, where do you put the 16? So since I know that the diagonals perpendicularly bisect each other, I'm going to put an 8 and 8 on that. The whole thing is 16, right? So I represented that as 8 and 8 because it got bisected. So I could set myself up a real nice, easy equation and say 3x minus 1 has got to equal 8. Add 1, divide by 3. And they wanted me to find x, so we did. Cool. Let's move on to, finally, the square. Right? The square is the king of it all. Right? Its parents, most obvious, 4 right angles and 4 equal sides. That's the rhombus and the rectangle put together. So, definition, 4 right angles and 4 equal sides. If this guy has 2 symmetry lines, right, which are the perpendicular bisectors of the sides, and this guy has 2 symmetry lines, which are the diagonals, obviously the diagonals and the perpendicular bisectors of the sides are different things, right? So this guy's got 2, this guy's got 2. That means a square will have 4 symmetry lines. The diagonals, which I have drawn right here, the diagonals are symmetry lines, and the perpendicular bisectors of the sides. Right? It's got 4 total symmetry lines, the diagonals and the perpendicular bisectors of the sides. And that's just a pretty obvious marriage right there. It's just boom and boom. So on a difficulty level, if you know this and you know this, I call that a difficulty level of 1 right there out of 10. When it comes to the diagonals, let me get rid of my highlighters. When it comes to the diagonals themselves, check it out. There's peanut butter every day. We definitely have a P, right, in perpendicular. We got a B right here and bisect each other, and we got a B right here and bisect each other. It's over on both parents, but you only get it once. You don't have to write it down twice. And we got an E right here. So the diagonals should be equal, right, and perpendicularly bisect each other. It's the only one where all three topics happen. They do intersect at a 90. They do cut each other into 2 equal pieces, and they are the same length. So boom, 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 boom. When it comes to the diagonals of a square, it's the king. It gets all 3 guys at the same time. They are equal and perpendicularly bisect each other. Right? All 3 things happen. So what we're going to do is realize, here's what they give us. Given each set of vertices, determine whether boom, parallelogram ABCD is either a rhombus, a rectangle, or a square. Then cross out, list all that apply. We're not going to do that. But we are going to explain. But back to this. They told us from the get-go that when we was to plot these points and graph them, it's already a parallelogram, right? They want us to realize if it's a rhombus, rectangle, or square by finding some more information. Well, take a wild guess what we're going to figure out. We're going to figure out information about the diagonals because it's going to be very, very easy to do that. So back to our hierarchy. We already know that this guy is a parallelogram, right? They told us that in the instructions. So we already know that the diagonals bisect each other. That is already happening. Now, what we need to figure out, is it a rhombus, is it a rectangle, or is it a square? We're going to find information out about the diagonals. We know that the diagonals are bisecting each other, right? So we have this down already. But if it was a rhombus, the diagonals should also be perpendicular to each other. So if we find the slope, right, and the slope of the diagonals, I should say, and they're opposite reciprocals, then boom, that thing is a rhombus, right? So to do a rhombus test, all we got to check to see is if the diagonals are perpendicular. But if it was a rectangle, remember, the rectangle says that the diagonals should be equal and bisect each other. So we already know that they bisect each other because it is a parallelogram. It's already happening. So taken care of, bisect each other. All we got to check for, excuse me, is to see if they are equal by doing the distance formula and seeing if they're the same length. So that would prove that it would be a rectangle if the diagonals were equal and bisect each other. But since we had to test for a rhombus, check to see if they're perpendicular, and test to see if it was a rectangle. What if it was a square? Wouldn't the diagonals be equal, which we've already checked for here? The diagonals should be perpendicular, which we've already checked for here, and the diagonals should be bisecting each other, which we already knew from the get-go. So all we have to do is find the slope, see if they're perpendicular, boom, find the distance, see if they're equal, and then if it was only equal, it'd be a rectangle. If they were only perpendicular, it'd be a rhombus. If it was both, it'd be a square. So easier than you think. All we have to do is find the slope and find the distance. And I'll show you a secret. So let's find the slope of the diagonals first. First slope we'll find will be the slope of segment AC. And this is where we really want to take our time and not make any sign errors. It's going to be y2 minus y1, 2 minus 2, over x2 minus x1, 4 minus 0, which is 0 over 4. Ooh, which is really 0. Don't freak out. Just because the slope is 0 doesn't mean that that's a bad deal. If the slope of the other diagonal was undefined, because a 0 slope is a horizontal segment, right? If we had a vertical segment, which the slope is undefined, then those guys are what we call opposite reciprocals. So let's find the slope of segment BD. And that's going to be these dudes, 0 minus 4 over 2 minus 2, which is negative 4 over 0, which is undefined. Boom. Those are opposite reciprocals because one slope is for a horizontal line, one slope is for a vertical line. They are definitely perpendicular. So we just determined that the diagonals are perpendicular to each other. Reason, opposite reciprocal slopes. Halfway home. The next thing we got to do is find the distance from A to C, which is one of the diagonals, and the distance from B to D. Now it's time to learn a secret. Right? Check these two formulas out. What we have just found is the slope. That's what M stands for. We found the slope, which is what's called the difference of your y's, right, where you take your y values and subtract them from each other, and then put that over your difference of your x's. Well, look at this formula. Doesn't this... I forgot something in this, my bad. 1 second. Squared. That would make that a whole lot better. So let me get back to where I was. My bad. This is the difference of the y's. Well, isn't this right here the difference of the y's also, except it's in the reverse order. So it's like, hey, order matters when you subtract, but not when you square something. Isn't that going to make that result positive? So we already have the difference of the y's, and here's the difference of the x's. We already have that figured out right here, and it's going to get squared. Who cares what order they're in? Check it out. Didn't we just find the difference of the y's right here, y2 minus y1, and the difference of the x's right here? So we have like all the work done for our distance formula, basically. We need to find the distance from A to C. Well, remember, that's why we label stuff. Here's all my information from A to C. It's going to be the square root of the difference of the x's, which is 4, and it's got to get squared, plus the difference of the y's, which is 0 squared. And you know what? People are like, what if you put those in the wrong order? What if you did 0 squared plus 4 squared? It wouldn't matter, because you're just adding stuff together. This turns out to be 16 plus 0. Isn't that the same thing as 0 plus 16? It doesn't even matter what order those go in. But we'll simplify. 16 plus 0 is the square root of 16, which is 4. So we just figured out that the distance from A to C was 4 because we already had all the work done with our difference of the y's and difference of the x's from our slope portion of this. So we can do that with the distance from B to D also. We have all that work done right here. It doesn't matter what order. What matters is that you got to put the numbers in parentheses because we've got to take that negative 4 and square it and add to it 0 squared. We got to put those numbers in parentheses. And then, boom. I'll do a little more shortcutting in my head. Negative 4 squared is 16, right? And 0 squared is 0. I'm not even going to write it, right? Because 16 plus 0 is 0. Square root of 16, distance from B to D, is going to equal 4. Boom! We also just figured out that the diagonals are equal. Right? So, since it was a parallelogram in the first place, the diagonals bisected each other. We also figured out that the diagonals were perpendicular. We also figured out that the diagonals were equal, so that makes this shape right here a square, to answer the question. Explain, here's our explanation. The diagonals are equal and perpendicularly bisect each other. Just what it says on our hierarchy, right? What's true about the diagonals of a square? They're equal and perpendicularly bisect each other. So we found all three things. We knew they bisect each other. Boom. We found out they were perpendicular because the diagonals have opposite reciprocal slopes. Diagonals are equal because we found them both. So boom, that was a square. Let's just do one more and then we'll call it a day here. So let me erase this. And here's what we want to do. Let's do like a rhombus test right here, and let's check to see if the diagonals are perpendicular. So let's find the slope of segment AC. This is where you got to really take your time and not make a sign error, because if you make a sign error during this, it's going to screw everything else up. You got to do 3 minus a minus 2, which is a plus 2, and you will get 0 over 5, which is 0. Again, so the slope of that is 0. If the slope of segment BD is undefined, again, they'd be perpendicular. So let's find the slope of segment BD, which is these two guys. -1 minus 3 over 2 minus a minus 1, which would give me -4 over 3. Obviously, those are not opposite reciprocals. What does that prove? That the diagonals are not perpendicular. Boom. Now it's time for the distance formula, which, like I said, we have all that work done already. The distance from A to C is going to equal these two guys squared. Here's your distance from A to C, or your A to C information. It's going to be 0 squared plus 5 squared, which is 0 plus 25, so you have the square root of 25, which is just straight up 5. If the distance from B to D is 5, then the diagonals would be equal. So why don't you set that up? Here's the info you want to use, right? Those are the two numbers. Let's square them. Got to go in parentheses if that thing's negative, right? Because a -4 squared plus 3 squared. Distance from B to D will equal square root of 16 plus 9, which 16 plus 9 is 25. Yes! Yes! So the diagonals are equal. So out of what shape is this really? It already was a parallelogram. The diagonals bisected each other. They're not perpendicular, but they're equal, so they're equal and bisect each other. That's got to be a rectangle. Reason: the diagonals are equal and bisect each other. So that there is our lesson. I know that excuse me, I know there's a couple more problems, but I think we get the gist of it right now. Let me know if you have any questions, and have a good one.